Hi guys, welcome to day 3 for our unit 11. We're going to be looking at the second part of our characteristics. So we're going to look at linear functions, exponential functions, and quadratic functions, and we're going to talk about end behaviors, average rate of change, asymptotes, vertex, and axis of symmetries. Now, some of those don't apply to each of the types of functions, so we'll look a little bit more on which functions they do apply to. The first thing we're going to do is just kind of give a little bit of a definition or remind ourselves what each of these characteristics are. So when we talk about end behavior, remember we're talking about what's happening at the ends, the right and the left end of the graph. So this just means that as we look right or left, okay, remember these are the x's, so as we look right or left on the x-axis, what is the y approaching? So I'm saying as I look to the right, what is my y value approaching? Are those y values continually getting larger and larger towards infinity? Are they getting smaller and smaller towards negative infinity? Are they actually approaching a number? So that's what we're going to see. We're going to see as we look right or left, so towards positive infinity or towards negative infinity, we're going to be saying what the y value approaches. Okay? The average rate of change, remember this is the slope between two given points on our graph. So that means we should be using, if we're going to use a graph, we can find the 2 points. So we get our 2 points. And then we're going to count the rise over the run. If you prefer to get the 2 points, then you can also do y2 minus y1 divided by x2 minus x1. So we know that this is the slope formula. Remember, rise is up and down, so this is the change in our y values, the second y minus the first y. And the run, those are our x values, that's left and right, so this is the change in our x values, which is x2 minus x1. So rise over run is saying the same thing as y2 minus y1 divided by x2 minus x1. Okay, an asymptote, remember an asymptote, it's a line that's not really part of our graph, but we draw it in with a dotted line, but it's a line that a function approaches but never touches. Okay, that means it's going to get closer and closer and closer to this invisible line, but it will never actually touch it. So it can infinitely get closer. So like if I say something's going to infinitely get closer to the number 0, I might have 0.25 and then 0.125 and then 0.05 and then 0.005 and then 0.0005, and those numbers are just going to get closer and closer and closer to the number 0, but never ever actually reach 0. Okay, vertex, remember our vertex is always going to be a max or a min, so it's going to be the highest or the lowest point on our graph, okay, and it's going to be an ordered pair. So it's going to be an x comma y, it's going to be an ordered pair that is going to be the max or the min. And specifically, it's for parabolas, so a quadratic. The axis of symmetry, sorry guys, is a line that's not really there, but it's a line, okay, specifically it's a vertical line. I did not spell that right, sorry. It's a vertical line that cuts the graph into 2 equal halves. Okay, So remember, this is the line that's going to show us the symmetry, where the left side and the right side need to be exactly the mirror image of each other. Okay, so let's go ahead and let's start filling some of these out. Some of these are repeated items that we've already talked about, and if you'll notice, these are the same exact graphs that we did on day 2 lesson. Okay, so example number 1, we have our linear function. So this is linear, it's a straight line. The domain of this is negative infinity to positive infinity. The range is also negative infinity to positive infinity. So here's the new things, the end behavior. So remember, this says as x approaches infinity. So remember, as my x values are going bigger and bigger towards infinity, that means we're looking to the right side of the graph. So as we look to the right side of the graph, so as we go this way, I'm asking, f of x is another way to say y. What are my y values approaching? Well, as we go farther to the right, my graph is going to go up, 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 up forever. So these y values are just going to keep getting bigger and bigger and bigger, and so they're going to keep approaching positive infinity. As x approaches negative infinity, so as we look to the left side of this graph, my y values are approaching what? So as we go left, this graph is going down, 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 down. So that means these y values are going to get smaller and smaller and smaller, and they're going to approach negative infinity. Okay? Average rate of change, because we have a graph, I would just do rise over run. So let's find these two places on our graph. So when x is 0, so here's where x is 0, so let's go down here and find our point on our graph. Okay. Then when x is 2, so here's x is 1, here's x2, so that's up here. So now all we have to do is count the slope from this point to that point, starting from the left and then going to the right. So we're going to rise and run. So this is rise 4, run 2. So if we rise 4, run 2, we are going to get a 2. Okay, that's just telling us the slope from this point to that point of this function. The second one, the average rate of change, this one wants the intervals. Please remember, this interval is giving us x values, so we need to find the y values on the graph that go with it. So when x is negative 2, that's all the way down here at negative 5. And when x is 1, that's up here at 1. So we're going to count rise over run. 1, 2, 3, 4, 5, 6. 1, 2, 3. So this is a 6 over 3. Well, that also comes out to be 2. We should be noticing that those are exactly the same because linear functions have a constant rate of change. That means no matter what 2 points you pick on a linear function, you should always get the same exact slope. Well, look, isn't our slope of this linear function 2? So I should be getting 2's for all of those. Okay, let's do the next one. We'll move through this one a little bit quicker. Okay, again, this is a linear function because it's a straight line. The domain of this is negative infinity to positive infinity, and the range is also negative infinity to positive infinity. As we look to the right, so as my x's get bigger, my y's are getting smaller and smaller, so they're getting lower and lower, so these ones are approaching negative infinity. As x approaches negative infinity, so as we look to the left of this graph, these y values are getting bigger and bigger, they're going up, so positive infinity. Okay, another average rate of change, so we see where x is 0, so that point is right here, and where x is 2, that point is right here. Okay, that's not very clear or easy to see, so we could plug that in using our point on our graph. So we've got this first point is 0, 2, so this is going to be x1, y1, and then here this point is 2, Now we need to know what that y value is. The easiest way to do that is plug a 2 in here. So if we plug a 2 in, I'm going to get negative 1/3 times 2 plus 2. So this is a negative 2/3 plus 2. Okay, so that would be 2 minus 2/3, or if we write this out as a fraction, okay, with a base of, or a denominator of 3, it is going to be 6/3, because 6 divided by 3 is 2. And if I subtract 2/3, we're going to see that this is 4/3, okay, which is 1.3 repeating. So we'll just use a 4/3 here. Okay, you might want to be using your calculator for that. If you struggle with that, that's okay. If we do, this is x2 and y2, so 4/3 minus 2 over 2 minus 0. This is a 2. Again, if I change this to have a denominator of 3, so this is going to be a negative 2/3 divided by 2. I know I'm going through a lot of algebra here. It's okay, just use your calculator. I'm just not using one on this. So negative 2/3. We're keeping the fraction. We're going to change division to multiplication, and we're going to flip this bottom to be 1/2. We'll notice those 2's cancel, giving us a negative 1/3. Okay, so that just means that we're actually going down 1/3 over 1, down 1/3 over 1. Okay, so that's going to give us our reduced final answer. That one was kind of hard to see. Let's see if negative 2 to 1 is a little bit easier. So negative 2, it's not going to be easier. It would have been easier if we would have had like a negative 3 to a 0 or a 0 to a positive 3. We could have seen that this was down 1/3. But on this one, we'll also get a negative 1/3. So we're seeing these are the same, and it's giving me this. Now, I could have just straight jumped to this slope and put that over here. That would have been just fine. Okay? All right, let's look at the next example. All right, so we've got an exponential. So we're looking at this one. We can see from the equation, we can see from the graph that this is exponential. Okay, so exponential functions do have an asymptote. So remember, your asymptote is always going to be whatever's added on here at the end, or it's going to be what this is getting closer and closer to. So we're going to see here, this is getting closer and closer to this y value of 0. So our asymptote is going to be y equals 0. Now our domain on this, we did this domain before, it's negative infinity to positive infinity. The range of this function, remember ranges are y values, so the lowest that this graph is going to go, okay, notice that we're approaching this asymptote at y equals 0, but we'll never actually get there. So that means we're going to get closer and closer to 0, so I'm using the parentheses, remember, and then it's going up forever. The highest y value is going to approach infinity. Okay, so as we talk about the end behaviors, again, this is the new part here. So the end behavior part is, again, as x approaches positive infinity, so that's to the right, this one is getting closer and closer to my asymptote at 0. As x approaches negative infinity to the left, we are going to approach positive infinity. Our y values are going up and up and up. Okay, I'm going to pause right here, and I'm going to pick up the rest of these in the next video.